Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Hi everyone, I would like to welcome you to the next episode of our webinars on AI and work, which are co-hosted by the ILO and ITU. The full webinar series can be viewed on the ILO AI Observatory page, and you can also find there a range of publications on the topic of AI and the world of work. Let me introduce today's speaker, Jim Besson. Jim is an economist, a technologist, and the executive director of the Technology and Policy Research Initiative at Boston University School of Law. And Jim Besson is a perfect match for our webinar series. He is one of these names that everyone working on AI and work knows and reads. In fact, I think each one of our recent papers at the ILO on AI and work has cited his work. And Jim's research has also been cited by many institutions, for example, the US Supreme Court, the European Parliament, and so forth. His publications offer us deep insights into the ways that technology shapes our economies, jobs, skills, wages, or affects inequality. And Jim has a unique perspective because he combines the academic rigor with hands-on experience as a successful innovator and a software CEO. Today's webinar is titled, "What Will AI Do to Our Work?" And we will start with a 30-40 minute presentation by Jim, in which he will share his thoughts on AI's transformative potential, and he will draw some lessons from the history of previous technological transformations. After that, we will have a discussion with some questions from my side and also some questions from the audience. So please post your questions online, and I will do my best to group them and pass them on to our speaker. So with that, welcome again, Jim, the floor is yours.
Thank you. I'm glad to be here and have this opportunity to speak with everyone. Let me share my slides. There we go. What will AI do to work? And that should be good. So if you follow the conversation and all, the big answer is it will automate our work. There is just an overwhelming flood of newspaper reports, of academic papers about automation. And the focus has been largely about automation. Part of this is fueled by hype. Part of this is fueled by excessive claims, excessive fears about automation. But part of it is very clearly real. But I want to emphasize automation isn't the only thing AI will do, and maybe not even the most important. It also will bring benefits to consumers that affect demand, and that in turn affects how automation will alter employment and job work. And it also will change the nature of our organizations and the nature of skills workers need to acquire, and how often they need to acquire those skills. Okay, so let me start with a couple general points to help. I think there is some confusion. People talk about automation, and what they mean by that is machines completely replacing humans. And the fact is, we've been experiencing automation for hundreds of years now, and automation tends to replace specific tasks, not complete jobs. So I did a study I looked at the detailed occupations that are listed in the 1950 US Census, and I tracked down which of those are still listed in the census today. Now, there's some change in how the census organized things, but what I found of those occupations, there were 30 some that disappeared because things changed. We don't have boarding house keepers, which was an occupation in 1950. It's not an occupation listed today. There were 4 occupations that changed because of technological obsolescence. The entire industry disappeared. So telegraph operators disappeared from the listing. They weren't automated. They were, telegraphy was completely replaced by telephony. And there was one occupation, only one that I found, where a job was more or less completely replaced by machines. That was the elevator operator. Most elevators operate on push buttons now, and they're self-operated by the passengers. So it's a mistake to think about automation affecting an entire job. Even though automation may only affect specific tasks, it may still have major effects on jobs, on skills, on wages, but we're confusing things if we're thinking about automation mainly about replacing people. So here's an example. Radiologists. So Jeff Hinton, Nobel laureate, he's really the father of deep learning. About 10 years ago or so, we were starting to see deep learning being used to scan X-rays and to scan them to identify lesions. That's a task that radiologists do. And in some of these tests, the machines did better than a panel of radiologists. So here's Jeff's prognosis on that. And let me play this short clip.
Let me start by just saying a few things that seem obvious. I think if you work as a radiologist, you're like the coyote that's already over the edge of the cliff, but hasn't yet looked down, so doesn't realize there's no ground underneath him. People should stop training radiologists now. It's just completely obvious that within 5 years, deep learning is going to do better than radiologists. It's going to be able to get a lot more experience.
Well, okay, we're well beyond 5 years from 2016. And what we have today is, in fact, a shortage of radiologists. And that's despite not only AI, but also despite extensive offshoring in the US. So we are seeing AI being used by some radiologists as a tool, as something to help them, to assist them in their tasks. But interestingly, there was a report just came out. It helps some radiologists, but it worsens the performance of others. It's not a slam bang, and it's hardly going to replace radiologists anytime soon. And the key thing here is scanning for lesions is only one of many tasks. First off, it's a task that has to be done in the context of the patient's medical history. So the way you interpret that evidence on the X-ray depends on what else you know about the patient. It doesn't deal with many of the other things radiologists do, like recommending treatment, recommending follow-up, and treating the entire patient. So it's not about to replace the entire job of radiologists, but on the other hand, it certainly is going to affect some tasks that radiologists do and is affecting them. Okay, so if we're going to talk about automation mainly about eliminating tasks, does it still eliminate jobs? If the machines do humans' tasks, does that lead to lost jobs? Okay, so here is the weave room of a textile mill in New England. This was about 1910, a little over 100 years ago. And what you see is lots of machines and very few workers. So automation at that time enabled one worker at the best mills, to handle 18 different looms all at once. Over the course of the 19th century, in fact, the labor of weavers in these automated factories had been dramatically reduced, 98%. So the time it took a a weaver to weave a yard of cloth at the end of the century or early 20th century was about 2% of what it was on the hand looms at 1814 or whatever. So dramatic automation. And it was done one task at a time, but not all tasks were automated then, and not all tasks are automated even today. Nevertheless, when we think about automation, we tend to think about it destroying jobs. So here are the weavers' jobs from the mid 20th century to more recently, and we can attribute almost all of that loss, or the majority of that loss in jobs, to technology, to automation. But this too, we need to put in some perspective. So here, literally, I'm putting it on a graph where we can look at the entire timeline. And if you go back to the beginning of the 19th century, when all of this automation was taking place, you see that automation was accompanied by rising employment. So what happened here? What changed? Why was it that automation left us steep job losses at some period and steep job rises in other periods? Well, it's a story about the effect on consumers. So here's what happened. The machines made it possible to weave a yard of cloth with less labor. That meant ultimately in a competitive market that cloth was sold at lower prices. When the price went down, consumers bought more. That's standard economics. Because demand at that time was hardly satisfied, demand went up a lot. So that in fact, there was more yards demanded. So many more yards were demanded that employment went up. So here's the amount, a logarithmic graph of the amount of yards of cotton or synthetic cloth per capita, consumed per capita. So in the early 19th century, when automation was just getting underway, the curve was steep. Demand increased a lot. But back then, cloth was very expensive. The typical person only had one set of clothing. Cloth was not used for things like, not used very much for things like curtains or upholstery. By the mid 20th century, well, people had full closets of clothing. They had a lot of cloth, and cloth was being used for all sorts of other things. So demand at that point was satiated or relatively satiated. Over this entire period, automation was improving the productivity and decreasing the cost by a similar amount, roughly 3% a year. And it's been doing it since then as well. But the response of consumers was very different because early on, demand was not well met. Later on, it was well met. Well, are things different now? Here's the bank tellers, what happened to the bank tellers with ATMs. So the solid line is bank tellers. The dashed line with the pluses is the number of ATMs installed in the US. And what we see is that between 1995 and 2005, there was a huge influx of ATM machines, but the number of bank tellers actually increased, surprising some bank executives, in fact. So again, this also is a story about demand, a slightly different one. The automated teller machines meant that there were fewer tellers required per branch. So that meant it was cheaper to operate or to open a new branch. Well, the banks were trying to compete geographically then, and so they wanted more branches. And making it cheaper, they opened more of them so they could provide better service and acquire more customers. And so as they opened more branches, even though there were fewer tellers per branch, the total number of tellers increased. Okay, so that's one aspect, that automation can increase or decrease employment. What about skills? So the same partial automation effect also affects skills. It raises output, but what that means is that the remaining tasks become more critical, and skills on those tasks become more valuable. Not always, but often. So we can, we can see this in the weavers, we can see this in the bank tellers. So here are, the initial weavers in the early 19th century. They tended to be, and this is in the US, it's different in Britain and other countries. but in the US, it was teenage farm girls. Uh, they were literate. Schooling and education was very big and very important in the US, but the mills particularly hired literate workers. They had no technical training whatsoever. They might have done weaving at home on a home loom, but that was rather different. But the fact is, as things became automated, even though there were fewer tasks to do, the ones that were left became more critical. So they had to monitor and manage multiple looms, and they had to quickly repair errors. If they didn't monitor things well, or if they didn't quickly repair errors, the machines would be down for long periods of time, and they would lose their productivity. These were very specialized skills to the looms, um, but it meant that they learned these skills on the job. So here is the average productivity of newly hired weavers at a mill in Massachusetts, not far from here, not far from where I am. And you see that the productivity, the yards a weaver produced in an hour, went up dramatically over the first year on the job, so-called learning by doing. Well, that learning by doing has an implicit economic cost, an implicit investment. And if we calculate it, it turns out that it's substantial. So, in this period around the 1840s, I calculated that the investment in weavers learned on the job was about $162. At the time, $162 was big bucks. Um, that was comparable, though, to what male carpenters or male masons were would what their apprenticeship investment was equivalent to. So even though these were just teenage girls rather than relatively privileged male tradesmen, the investment was similar. The skills were significant. And in fact, as the skills accumulated, weavers' wages rose, and they rose substantially so that weavers became a lower middle class occupation. Here's at the turn of the 20th century, mill girls showing off their finery, which they could afford. Bank tellers, a similar change. Um, as the cash handling became less important, as that was automated, not entirely, but substantially, marketing related tasks became more important. Communication skills, interpersonal skills. They were there dealing with the customers. The customers who tended to come in were local businessmen typically, and they were ripe for CDs or for loans. So the bank teller established a relationship and kept an eye out and promoted various other services the bank could provide. Um, so they were a different set of skills, and gradually the banks have begun changing the nature of the people they hire to be tellers. There are more full-time workers. It used to be largely a part-time job, and they're more educated workers. Not predominantly, but you're seeing more bank tellers who have college degrees. Similarly, we see things with AI now just emerging, but the requirement of so-called prompt engineers to deal with large language models. More importantly, I think you see a variety of hybrid jobs emerging where the job requirements are, somebody who has marketing skills and knowledge of marketing and maybe specific industry knowledge, but also who knows how to work with AI tools. So there are changing skills. Automation also affects organization. Hold on a second. So one thing automation can do is it can affect the division of labor. It's commonly said that word processing software automated the job of secretary, and that's not quite right. There were a number of studies done when word processing was coming on. It's exactly how much it improved the productivity of secretaries. And it was in the range of 10 to 30%. Not insignificant, it was important, but 10 to 30% isn't going to lead to a tremendous drop in the employment of secretaries that we actually saw. But there was something else going on. It changed the division of labor. So, what word processing did, its key benefit was that it facilitated the retyping of revisions. You didn't have to type in the whole document again. You just could make the changes and keep the original text, modify it directly on the screen. And so there was much less involved in doing that. But while that reduced the time for a secretary to work on a document, it also meant that professionals could more readily do their own revisions. So that led to a massive shift of work from secretaries to professionals. Professionals now do their own typing for the most part. Secretaries are used for some things in typing, but secretaries' tasks have become much more diverse relative to just typing. So this wasn't strictly automation in the sense that the work of typing was taken over by machines, but it meant that rather than machines replacing humans, machines let one group of humans replace other humans. It changed the division of labor, changed the organization. And that's something we need to be keyed into as well. There are other sorts of organizational changes. One is the barcode scanner. So the barcode scanner helped automate the work of the checkout cashier. And studies found that it reduced the labor costs in retail by about 4 or 5%. Well, that's not, again, not a very big change, but a tremendous change in terms of what kind of systems some of the advanced retailers were able to build on top of this technology. So it led to inventory management systems. These were used to speed deliveries using logistics. The stores could track the sales of different items in each store, track where they were going, track when they needed to be replaced or fulfilled. They could organize the delivery, the warehousing, the trucking much more effectively, so they could speed up deliveries. This also allowed them to employ much greater selection in stores. So they increased the number of items in stores because they could much more efficiently handle the flow of goods into the stores. And they could do things like respond more rapidly when demand changed, when there was a hot item. So some firms were able to take advantage of these new type of systems. They changed their organization. They changed the way they worked with their buyers, their store managers, and even their suppliers, so that they could all work together to more successfully respond to changing demand, provide greater selection, do it quickly. And the stores that were successful in building these relationships and systems came to dominate retail. I wrote in one of my books about this tremendous success of Walmart in the United States, which became the greatest or the most dominant general merchandise retailer using systems like this. But it's not just them, it's all over the world. So generally, are things different this time? And sure, there are some important differences. For one, we talk about the 19th century, we're largely talking about automating blue-collar jobs. Now we're talking about automating white-collar tasks. Well, that makes a difference, but it's a difference in who gets affected, not necessarily in what the kind of effects are, or what are the economics of changing AI that's going to affect jobs and skills, et cetera. It's sometimes argued that the rate of change is faster today. I'm not convinced that that's true. And a number of people have proposed that, but I've never seen really convincing evidence. And it's very hard, it's very hard to do when you're talking about vastly different sorts of technologies that are hard to measure. But even if it changed the pace at which things changed, the pace at which technology advanced, that doesn't necessarily mean it's a different result. If in fact technology is increasing demand faster than it's decreasing the labor required, this is what we saw with bank tellers, this is what we saw with weavers. A faster rate of change is going to mean a faster growth in employment. It doesn't mean a change in the sign of the direction of the change. So a lot of the difference comes to the question, what is going to happen to demand? Are there, in fact, large unmet demands today in various markets, or is demand largely satiated in most markets where this technology is going to lead to job losses? So you need to think very carefully. Are these markets satiated? I think it's pretty hard to say that healthcare is satiated, that people are getting all the healthcare they need. I think it's pretty hard to say, certainly in the US, that housing market is satiated, where we're seeing housing shortages and house prices rising. It's not clear that financial markets are satiated. Banking in particular, there are still lots of people who don't use banks. There are still lots of unmet needs out there that aren't being met. So if we want to think about the impact of AI, we need to think about the near future and even the distant future. What's going to happen to some of these? Can we ever have too much healthcare? And I think there's an argument to say that that's a good where you can never get enough. As you get old, you may feel that sometimes, but certainly it's a plausible idea that there may never be too much healthcare. There are other kinds of goods economists call status goods, or things like fashion and design, where I want to buy something with a distinctive fashion to distinguish myself from other people. Well, that's always going to be true. Fashion changes, design fashions change, so that there's constantly something new that we demand. And finally, there's some occupations involve interpersonal goods and services, that the communication with a human is an important part of the customer-buyer relation, the customer-seller relationship. Maybe we'll get bots in the future that do a good enough job of mimicking human behavior so that I feel comfortable getting advice from a bot. We're clearly very far away from that right now, but there is a frontier there where demand might not disappear. The other sort of argument is that, well, we're going to have complete automation. Computers are going to have so-called artificial general intelligence, where they won't just be automating tasks, they'll be automating entire jobs. And some people have been saying for some years now that, well, this is just a year or two away. I think if you look at the actual progress, and if you look at what machines can actually do in the workplace and are actually doing in the workplace, it seems very hard to believe that it's a year or two away. And I'm quite skeptical of those people who say that. I tend to think that this is not likely in the next several decades. It's quite far away and may never happen. But that's certainly open to debate. I think another critical thing is the burden of automation. So the whole focus has been on automation replacing humans and people losing jobs. And that's not where the burden is falling. So we did a study. The Netherlands statistical agencies have been collecting data on automation for well over 10 years. I think our study went back to the early aughts. And so we had every firm, every plant, and we knew how much they were spending on automation activities. So we could see what happened when they made major investments in automation. Some investments in automation were just sort of maintaining the automation equipment. But when we saw a major increase, we could look and see what the evidence was. And there wasn't clear evidence of the net number of jobs decreasing. It's a little bit tricky because what we found was, and this is typical of studies on automation, is the firms that are automating are the ones that are growing most rapidly. So they're increasing their employment before they automate even. So it's hard to know how much they would have increased without automation. Within the firms that we saw in the Netherlands, we did find that more workers left the firms, but more were hired also. So the big change wasn't on net automation, but there was a burden on those who left. So there were more of them leaving, and they lost pay in their transition to a new job or into retirement. Despite a safety net, a social safety net, the support that the safety net provided was small relative to the pay that they lost. They there were no, or the institutions did not seem to play a good job in speeding their transition to a new job, and that the burden was heaviest on older workers. These were the workers who were least likely to get training in a new occupation or new field. But the key thing is the focus has been on losing jobs, and the real issue is the transitions to new jobs, to new skills, to new occupations, to new locations. And in all of these cases, it's a burden that falls on the individual workers. The institutions of society in terms of a safety net or in terms of training and other sorts of relocation support were not doing a good job of smoothing the transition. So there's a double reason why this is important. One is, of course, to help out workers who are being harmed by this technological change. But the other is the more that you facilitate people moving into the new jobs, new skills, new occupations, new locations, the more you are you are easing the what it takes to employ automation. Automation is going to happen more positively when workers are provided with the skills and capabilities to make the most use of it with new sets of skills. So this is sort of the big policy focus that I come to, that the challenge is we have moved away from a world where people are educated when they're young, and we think of them having a set of skills to last at least 20 or 30 years, if not an entire career. We have to think now about lifelong learning, that people have to have the skills and capabilities to learn new skills periodically over time. Some of this involves learning on the job, as the weavers did. Many of the new skills, there's some studies of technology workers learning on the job with new AI systems. So we have to figure out ways that workers can get access to jobs where they can learn. And there's some studies showing that worker participation is key in guiding the employment of new technologies in ways that allow workers to adapt to it and use it in the most effective way. So these are the challenges of transitions. So to summarize, automation can decrease jobs or it can increase jobs. And the increases can take a long period of time. For the weavers, it was over 100 years. And this is happening even with today's technologies. Automation can increase the demand for skill. It can also decrease demand for skill in certain cases. But while some skills are eliminated, new skills can be important. And third, there are organizational challenges to creating a skilled workforce, a newly skilled workforce. We need to change the way our educational institutions work to encourage lifelong learning. We need to develop ways of allowing workers to learn new skills working with the new technology. And we need to encourage institutions so that new skills will lead to higher pay. Thank you.
Thank you so much, Jim. This was a great presentation, very much in line with everything we have been discussing in this webinar series. And let me kick off the discussion. I was actually very happy that you gave the example of prompt engineers, prompt engineers or prompt designers. I think it's one of those that we hear all the time when people are asked about new jobs that will emerge, which is, of course, such a difficult question. But the way at least I think about it, it seems to me that jobs like prompt designers or engineers is a very niche occupation that might even temporarily replace essentially what is a lack of skills of using these technologies on the job by people who currently don't use AI. So how do you think about that? You covered that partially in your presentation, but do you also have thoughts about completely new occupations that might emerge from this transition? Or do you maybe observe already things in the statistics that, at least in terms of tasks, reshape occupations, at least in the US market?
Right. So I think there's two things. One, it's really hard, and I'm not going to offer new occupations, entirely new occupations. But it's important how we think about some of these things. So when you think about what the weaver's skills amounted to, in a sense, the weaver skills were complementing the weaknesses of the machinery. The machines would make errors. The threads would break. If they could design a perfect loom, there would be no work for these weavers. So a prompt engineer is the same sort of thing. It's developing a set of skills to overcome the shortcomings of the technology. Now, prompt engineers are related to LLMs, large language models, which has been a source of tremendous hype, tremendous experimentation. I'm not convinced that the sort of out-of-the-box large language model, the ChatGPTs of the world, are necessarily the most important AI application development that's going on. You're seeing much more specific systems. So you're seeing systems, for instance, where some of that technology has been adapted for customer support applications, where it's combined with humans. And in some cases, it plays a role, but the humans have to pick up some of the shortcomings. You're seeing AI being used to help computer programmers, software developers, so-called Copilot, the Microsoft GitHub Copilot. And again, the specific skills of so what happens is software developers develop techniques for working with this new technology, and it can help them in some cases. So the picture's kind of mixed. It doesn't help all software developers. It seems that it helps the less skilled ones. But overall, it's probably improving things. But it's hard to know what is just a temporary shortcoming of the of the technology that's being addressed with skills, and what's going to be a longer term issue or skill that's needed. And partly it depends on the trajectory of the technology.
I often use myself Copilot or similar tools to write code, and it's super helpful, but so far from replacing someone's foundational skills of knowing how to code, of understanding how to write it. And that's really my question also, as a continuation of the discussion, because as your example of ATMs shows, and it's one of those I actually myself very often cite your work about in my presentations. It shows that people transition, but it's often not the same people, like you said, that find the new jobs. And it's very often has to do with these foundational skills, the ability to use a certain technology. And maybe those new tools require a different set of skills, foundational skills, to be able to perform one's job more efficiently with this technology. Using Copilot requires some understanding of code and setting up all these applications on one's computer and so on. And that typically excludes certain demographics. For example, older workers were more excluded in the previous technological transition. So how do you think of that? And are there some lessons learned from the past that could be applied now to shaping policies to avoid this kind of costs on individuals and help them transition?
Right. So you threw a lot of things at me there.
I'm sorry. Yeah.
No, no,
It's,
no, no.
it's my opportunity.
Let me just make sure I don't. I'll start talking, and if I've forgotten something. So let's start with the software developers, right? So first off, it's important to put Copilot into some perspective that since at least the 1980s, there's been a tremendous amount of automation, whether you call it that or not, in software development. So the government keeps price indices of the cost of the price of prepackaged software, things that Microsoft makes, that sort of stuff. And it's been falling by 6% a year since the 1980s. That's tremendous. I mean, that effectively says since the 1980s, the cost of software is only 10% of what it was, but back then, several decades ago. That's largely due to greater efficiency of the programmers. It's largely due to some form of automation. So this has been going on quite a while. Of course, the number of programmers and the pay of programmers, software developers, has continued to rise robustly also. So we can say that, we can infer loosely that this is rising demand. But always, programming has been an occupation where people, a new thing comes along and you have to learn it. So a good software developer learns new skills, new languages, new techniques, new ways of working with other programmers. And this has been going on for decades now. It's built into a lot of the way that software is taught, but it's not enough. I mean, there are clearly, COBOL was a language that was used extensively in the 1960s, and you still have some COBOL coding going around, and you still have some developers who are stuck, using older techniques that are really not at the cutting edge, and that's okay. Maybe that's okay. But I think we can look a little bit at the ways that software developers acquire new skills, and what you see is a tremendous online learning community where you can take courses and pick up new skills. You see foundational skills being taught in computer science courses these days, or at least the good ones. So that people are getting the conceptual ideas that are going to let them adapt to specific changes more readily. In a way, we need to expand that model to many other occupations. We need to change our educational institutions, even in high schools or whatever, that things are being learned in a way, and we need to be able to focus on learning new ways of learning, new ways of acquiring skill. What did I leave out?
Well, the demographics was one of the questions, sort of the older workers. And is it as easy for everyone to learn those new things? If you were not working with a machine, with computers and AI, as an electrician, will it be that easy to pick up suddenly how to work with AI and image recognition and reading manuals, and many other occupations that will be affected similarly? How do you see that?
Yeah. Well, first off, critically for older workers, there's a real problem. And that problem's been around for a while. And I'm not sure what the solution is. But I think there are many middle-aged or younger workers, who have been trained in a more vocationally oriented system. And we have to think about ways to getting these workers to acquire new skills. So there are people experimenting things with new kinds of apprenticeship programs, pairing on-the-job experience with local community college. I'm most familiar with in the U.S., but the workers can go to the classroom 3 days a week and be on the shop floor 2 days a week, or something of that sort. I know in Germany they're experimenting. I mean, they have a very well-established apprenticeship program, and they're experimenting with changes to it in order to deal with these things. So there's a big challenge. Um, I think one of the lessons I got from studying the 19th century was, it took a long term time. It took decades for the the textile industry to figure out how to train its workforce, and they went through different models. Um, but only after several decades did they really emerge with something that's like the modern industrial model, where it's not hiring farm girls to come and work at the mills for a few years. It's a local residential workforce where people work and learn on the job and become essentially skilled by working on the job. Uh, but and they can recycle then and back into the industry. And I won't go into the details of what changed then, but it was remarkably difficult and time consuming to develop to develop the kinds of institutions to provide the workforce. But with any technology, it requires a massive core of workers of all different sorts in different occupations to be able to work with the technology and use it. Um, and it's not just, I mean, we tend to think of technology coming along and affecting the quote unskilled workers. It's much more complex than that. The technology doesn't succeed unless it's got workers who are acquiring skills. They may be short-term skills like prompt engineers, possibly prompt engineers, but the entire if you span the entire range of occupations that have to deal with the technology and adapt to it, it's really a big social change in terms of building that skilled workforce, newly skilled workforce who has the skills to work with the new technology. And we're just beginning to experiment.
Yeah, I guess it's just the beginning of the change we're seeing, as it seems. And let me pick up here on mix some of the questions from the audience with the questions I was also thinking about. We clearly have people who have been watching the series, so I'll pitch here a question that comes from the discussions we had with previous guests, like Darren Acemoglu, like David Otter, who sort of hinted also in the writing that the current phase of the technological transition and the AI technology seems to have too much of an angle on automating existing tasks. And that maybe that's what is different to previous technologies. So let's say invention of a plane gave humans a completely new set of abilities. But here we have a technology that essentially maps out the digital trace that humans leave online, trains AI to replicate it one-on-one, and automate as much as possible. Do you, as a technologist, do you feel that this might be different, or maybe there's too much focus on pure automation rather than complementarity? And one of the things we've been discussing in this series is how to measure usefulness and complementarity of technology to humans. So I wonder whether you have some thoughts on that.
Ooh, all right, measure. Let me not forget that one. So I'm not actually convinced with the argument that Daron and David make. I mean, I like them both, and they've got very impressive things to say. First off, I don't know how you would measure it. When something is automated, that doesn't mean it can't lead to entirely new tasks and new ways of doing things. So I gave the example of the barcode scanner. Well, yeah, that was automation, and it was seen as automation as its first step, right? But the main impact was not that it replaced workers, but it enabled an entirely new system to develop. And that system led to, really a transformation in retail. One economist calls it an industrial revolution in retail. So how do you distinguish, so clearly that involves a lot of complementarity with the technology. where new jobs are being created, new ways of doing things, new skills are being required, even though nominally the thing that kicked it all off was automation of a particular task. So it just seems that conceptually there's some. I don't think they've recognized the importance of the systemic effects of technology. They've done a good job of identifying how automation of tasks can affect things within a narrow framework, but they're missing some of the bigger picture, unfortunately. How do we measure that complementarity? Well, I think part of it is by looking at, when technologies come in, what are the skills and occupations that are getting hired? What is its effect on net employment? And these are all things that are hard to measure. And we have disputing studies. But I think, overall, most of the studies are finding that automation, either it doesn't decrease jobs or it actually increases jobs. In terms of the kinds of skills required, we're seeing a more mixed picture. In some cases, lower skilled occupations, and I put that in quotes, are hurt. In some cases, it's the higher skilled occupation. Managers are reduced in terms of their percentage of hiring, or other skilled workers. So I think that the evidence is not yet clear about that, but it certainly doesn't seem overall that, when you see some significant complementarity between automation and skills, that doesn't seem like it's simply a matter of task replacement, or predominantly a matter of task replacement.
It's great to hear you disagree. I mean, to hear disagreement, especially with big names as well, and other guests on the series. That's, I guess, also one of the purposes here, that we have a discussion and different views. And thank you for your arguments here. So I have another question actually coming from the audience, but that blends very much with what we have been working on, which are the concerns about this new technology that is not only about job losses, but how it affects working conditions. And that particularly can take away autonomy of workers or increase monitoring. And the person asking whether you think there's a greater concern about these issues with this new wave of technological development than it was in the past. That these technologies, we've also been looking at that it's much easier to use them to monitor people essentially in real time by reading their emails, communications, and other things, especially if there is lack of regulation and sort of things that one's not allowed to do. How do you think about this? Do you see a greater risk in this case than in the past?
Right. Well, first off, I think there is some. I think there are two sorts of issues about. One is sort of an invasion of the employee's privacy, but the other is monitoring. And I think the key interest that employers have is monitoring for productivity. They want to find out who's slacking, right? So to some extent, so remember, I started studying the weavers, and the thing about the weavers is productivity is very transparent. Every month they measure how many yards of cloth each weaver produced, right? So if somebody's been slacking or hasn't been working well, they're paid on piece rate, so they're not getting paid as much. But it's pretty apparent, and if they're not working out well, they'll get fired. So part of the problem of monitoring has arisen more recently as work tasks have become more complex and less easily, less transparent. There's more of a quality issue involved. And the bank teller, it's not just how fast they can count out the cash, but it's how well do they interact with people, right? Do they have a bad attitude? Do they, and so it is true that the newer technologies probably provide some greater capability for employer monitoring. And there is some risk of that. On the other hand, where it's also pretty clear that Where the introduction of technology has worked the best, it has not antagonized workers, and it has, if anything, involved their participation. So, you're going to have some employers who are short-sighted and stupid and who misuse these tools in a way that invades employee privacy, overly monitors them, and you're going to have other employers who are much keyed back about that and want to facilitate worker participation and a sense that the technology is a tool that will make their jobs better.
Yeah, well, on our side, we have been also writing and saying it's very much a choice, the way technology is being applied at the workplace, and it's great to hear you confirm that perception.
Yeah, I don't have much idea about regulation. I think it's probably very difficult to regulate, but there are some, at least at a baseline, privacy things that can be regulated and are regulated to some extent.
I see that the moderator added us 5 more minutes, so I'll just ask you one more question that sort of is looking into the future. That's coming from the audience. I'm curious about your take on that, which is the prediction on the rise of cheap, below around $20,000 humanoid robots guided by AI that is on the horizon. And the person is asking whether you think this will be a slow march like self-driving cars, or whether you have different vision of the future and this kind of machines assisting humans advancing much faster.
So I'm not familiar with the specific robot they're talking about, but I
I think there is a
know.
range of humanoid robots mixing sort of AI abilities of image recognition and speech imitation with the abilities of machines and trying to provide assistance.
Yeah. So people have been trying to do this stuff for decades
time.
And it is getting better all the time, but it's getting better slowly. And it's not all that different than I think the problems of self-driving cars. There may be specific applications where a humanoid robot, there are specific applications where a humanoid robot with some basic capabilities can fit in and do a useful job. But on a mass scale, I don't see that happening yet because, it's basically the world is too complicated. Humans are too complicated. What we want and what's what we want is complicated. What's expected of us in the workplace is complicated. It's not one thing, it's many complicated things. And, so a driver has to be able to anticipate all sorts of things that machine learning isn't yet figured out how to do or what to do. And there's a concern about what are so-called tail events, the things that happen very rarely, but we have the sort of the tools, the common sense to know how to deal with them, and a machine learned intelligence isn't going to have that capability, at least not in the near term.
But there is something you have been writing about that is happening already. And I was reading your new book, or your recent book, The New Goliaths, where you talk more about the market concentration that's resulting from very few companies having access to these highly advanced technologies and using that to dominate the market. And I wonder what's your take about now the new wave of AI? Is it just leading to more even consolidation of this type of technology in the hands of a few, or do you also expect some kind of a breakthrough in decentralized AI technologies that would power more innovation among smaller enterprises, for example, and individual users, maybe just by AI offering a platform for this type of innovation, but allowing people to create completely new things? How do you think about that?
Yeah, so I think both tendencies are there. That I think in the short run, you're seeing a scramble to develop AI by a small number of large companies. And I think it's going to be sort of the same effect on steroids. But what I argued is that it's often to the advantage of a company with such technology to offer it as a platform. They can provide the tools without giving away the jewels, uh, to make it available. So that in the book I talk about, for instance, AWS, the cloud. So small companies can get access to sophisticated IT, large-scale storage, and AI capabilities on the cloud, and use them at least to some extent. So to the extent that that happens, that's going to be really beneficial. It's going to mean things are spread around more, that the technology itself is going to be more both decentralized and more widely used. But I think there's a particular, tightrope that companies face in terms of deciding to keep things proprietary or to offer them on a platform, of course, for a fee. But we look at case histories like of these companies deciding to offer things on a platform, and they were often, they're often very ambivalent about it up front because they don't know. It can expand their market, but can also undercut their proprietary advantage. And what we've seen is that they tend to lean towards staying proprietary. But when they have opened up, it's often been a huge success.
I guess also it's a question of the cost and accessibility for small enterprises. And of course, the digital divide in developing countries of many people not even having access to proper technology. But I guess we also have to leave that for another discussion because we've gone for over an hour. And now it's my time to thank you for this great discussion.
Well, thank you.
For the presentation and the discussion. I also want to thank our audience for their engagement, for the questions they sent. Let me remind everyone that you can find all the materials on the page of the ILO AI Observatory. And I want to thank everyone for joining. Thank you again, Jim. And I look forward to the next episode of our webinars. Thank you.
Thanks for having me. Bye-bye.
Bye.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.